Hi everybody, today we will talk about Internet of Things and the network protocols that are involved with this technology. I start by introducing myself. I'm Alesso and I work in Reply since 2019, specifically in anti-reply, where we develop some telemedicine software like Tipura, which is the masterpiece of this reply. Now we have TWB, which is a platform with which we deliver telemedicine through virtual reality. Then we have, let's say, that involves speech therapy.
Hello everyone, my name is Mohammad Naeem Akhtar and I am working as a cloud engineer in Storm Reply since 2021. The skills so far I have as a developer for the software development and the testing and research development. The projects that I have done so far are Themax IoT, which involves the collection of data from the industrial manufacturing machine to analyze the manufacturing process by collecting data and analyzing the data. And another project is export, transformation, and load using the Spring Batch framework.
Today, we have a brief introduction of IoT. What is IoT? Then I will talk about the protocols that involves also the physical layer, dividing them in short and long range. And my colleague will talk about IoT protocols that involve sub-layer like MQTT and CoAP. And then we will show you a short hands-on of how you could develop an IoT platform. So let's start.
Let's start from the introduction part. What is IR? IR is an acronym of Industrial Revolution. Klaus Schwab, the founder and the executive chairman of World Economic Forum, has argued that the Industrial Revolution is blurring the lines between digital, physical, and biological spheres. First Industrial Revolution started in Britain at the start of 1800 by the invention of steam engine, which has led to the creation of new manufacturing processes and the new factories. A century later came the second industrial revolution and was characterized by the mass production of steel, oil, and electricity. The light bulb, electricity, and the internal combustion are the key inventions of this era. Then, by the invention of semiconductors, internet, and personal computers, came like the third industrial revolution, which is also referred to as digital revolution. Then came the fourth industrial revolution, which has marked different technologies like AI, IoT, cybersecurity. IoT is referred to as the heart of fourth industrial revolution, which we are going to discuss more in the remaining part of this presentation. Now, what is IoT? Internet of Things or IoT integrates billions of smart devices that can communicate with one another with a minimal human intervention. The devices can be temperature sensor, a smart car, a robot, a security camera. It can be any device to collect data for the purpose of collecting data, sharing data, and analyzing the data. Now the thing is to understand the Internet of Things devices, which are part of Internet of Things, which are the important part of IoT. IoT device, the main features of IoT device is that it has to be securely connected to the internet. It has smart features. It has the capability to communicate and interact with other devices. With the minimal human intervention, it can be configured remotely. It is programmable. In case of any damage, it can be replaceable, and it is flexible according to the environment. If a device has all these features, we can say that it is a smart IoT device. What are the components of Internet of Things? This slide will help us to understand from where the data is coming and where it is going. On the left, you can see there are three IoT devices. It can be more. They are connected to the cloud through the IoT gateway. They can be directly connected to the cloud, but there are many problems. For example, there is a fire, and in case of the IoT devices directly connected to the cloud, the response time will be really slow. Here, the IoT gateway plays its role, and the response time will be really fast because it provides the edge computation. It also helps us to save only the useful data to the cloud. And at the end, we have the user interface, which helps us to provide the functionality to the users to interact with the whole IoT system. So in general, there are four main components of IoT. IoT devices, IoT gateway, which is available on the local area network, and cloud, and then the user interface. Now the thing is to understand the benefits of Internet of Things. It provides the improved customer engagement, and it provides also the technical optimization, which reduces the wastage and the cost. Because of remotely configurable and the automation, it provides the remote therapy like in the field of medical, and also safe environment because of automation. Also in the field of gamification and biometrics. It also provides the implementation of new businesses and to start the new businesses and to make the better business decisions because of data. These are the main benefits of Internet of Things. Now, what is the value proposition of Internet of Things? Whenever we talk about Internet of Things, we don't need to forget about big data and its security. When more than 50 billion devices were connected to the internet, you can imagine how big amount of data they will produce. This massive amount of data will be really helpful everywhere, like in revenue growth, cost saving, and the society will have the new value. Now the challenge is how to do that and to address the privacy of the personal data and the security and to secure it from the unauthorized users. These are the main challenges of big data. When there are advantages of something, there will be some more disadvantages of the same thing. Now, the business goals of IoT could be to improve the product quality and the lifetime of the product, to make it reliable and available all the time, to improve the efficiency, to improve the efficiency to reduce the cost and provide the workforce safety and government compliances. These could be the main business goals for IoT. What are the verticals of IoT? To make the whole planet smart, we need smart manufacturing, smart city, smart energy, smart health, smart buildings, smart transportation, smart military, smart agriculture. And by combining all of these, it makes us planet smart. In future, I would say that everything that can benefit from internet will be connected to the internet.
Hi again. I will try to make a big picture of which are the protocols involved in the physical connection between IoT devices. So before starting with the list of protocols, I would like to introduce you to the main problems of Internet of Things devices. Well, the protocol has to deal with other single identification. The trend is to provide an IP layer to unify all the devices with the project Connect and Home by IP, which is backed by company as Apple and Google. Most of the devices are battery powered. So that means that the transmission battery consumption need to be very low to provide years of battery life. There are two main ways of moving the information, with a single IP or with a mesh network. In the latter case, we need an optimal algorithm to compute the best route and to adapt the transmission following the network constraints. Data coming from and to the device need to be received, so fault-tolerant transmission algorithms need to be taken into account. And last but not the least, IoT devices could also move within the network. For example, we could see the fleet mapping. Then going on, these are the protocols which are going to review today. From left to right, we have the Bluetooth, the Z-Wave, Zigbee, Wi-Fi, LoRa, Sigfox, and narrowband IoT. These technologies could be divided into two main groups, as you may have noticed. On the left, we have the protocols for short-range IoT, which means until 100 meters from the gateway. Instead, on the right, we have longer-range IoT. That means about at maximum 10 kilometers from the gateway. Within this technology, we have also narrowband IoT, which is based on the architecture of LTE. That means that the network coverage is worldwide. Going on, data transmission of these protocols is lower electromagnetic waves. So to understand better how they works, It is interesting to see how various protocols place on the frequency scale. We could see the division between long range and short range directly from this graph. And most all the smartphone protocols are on higher frequency and long range on lower ones. In short, when you have a protocol based on a higher frequency, it can carry more data but have less penetration power, which means range. Lower the frequency, then we have less data, but devices can be farthest from the gateway. The only protocol which is used for smartphone application, which lies on the sub-gigahertz frequency, is Z-Wave, which they are also currently developing a protocol for long-range communications. Perfect. Then we are start to review the short-range IoT protocols. Well, starting from Bluetooth, it is developed by Bluetooth Special Interest Group, whose main partners are Ericsson, Sony, IBM, Intel, and Nokia. Mainly, Bluetooth is a wireless standard to exchange data between devices over short distances. And the reason why it becomes so famous is because the devices are directly accessible from your smartphone, which is always with you. Mainly it's used for smartphone and IoT, Internet of Medical Things. I want to make a short insight about this thing. In fact, as I said, I'm working for MedReply, which is a telemedicine platform. And within this platform, we integrated several Bluetooth devices, several medical Bluetooth devices. And I want to point out the difference of integrating the classical Bluetooth over the difference to integrate Bluetooth low energy devices. Well, in case we have to choose between them, you must know that low energy has standards for interfacing directly to the measurements you need and a standard also for how the data is structured. Instead, the classic Bluetooth allows the companies to use a serial communication. This means you will have to study the SDK and the set of commands you have to do in order to get information. Moreover, this kind of information is structured as the company wants. So this means that when you have to integrate a device on which is low energy, once you integrate a thermometer, for example, you have integrated them all because they always use the same standard. Instead, if you have to integrate a classic Bluetooth device, you have to integrate it every time from the beginning. This augment the time for developing. Perfect. Going on, next protocol is Z-Wave, which is a proprietary technology run by a company called Sigma Designs. And if your device says Z-Wave on it, means that it's licensed by Sigma. And the manufacturer had to adhere to strict rules to ensure maximum compatibility between devices. Sigma also exercises control over who can produce this kind of chips, and the producer is called Silicon Labs, that in recent years bought Sigma, so this is the reason. And the upside of this total control over the chip and the protocol is that it's extremely standardized, and you can always be sure that your Z-Wave devices will work with each other. Instead, the downside is that because it is a proprietary protocol, Sigma could charge whatever they want. So in the end, the devices cost more to the final users, and the final user usually are home users that want a smartphone. Going on, a similar technology to Z-Wave is called ZigBee, which is an open protocol based on 81.15.4, where individual companies have to implement their products without the strict set of rules like those enforced by Z-Wave. As a result, even though every ZigBee hub will be able to hear every ZigBee devices, it might not be able to understand what they are, what type of data comes from them. This slight difference in implementation of ZigBee devices can cause even larger issues due to the way they form the communication network, of which we will talk later. Then ZigBee is an open protocol and is used in sensor networks and over short distances. Going on then, the network formed both by ZigBee and Z-Wave is called a mesh network, where they can extend the range of the signal by relaying information from one device to the next. And the best case scenario is that this relay process extends the device's range while only introducing a minor delay or latency. But as the number of relay or hops increases, the delay can become very large. For this reason, Z-Wave introduced a maximum number of hops, which is 4 hops, and this constraint is not present in ZigBee networks. In order to increment the range, you have to place these repeaters between the hub and the next hop. It's also important to understand that these mesh devices must have constant power. So we are talking about light bulbs and switches that will act as anodes. Z-Wave and ZigBee are lightweight protocols without too much fault-tolerant algorithm. Instead, the next algorithm, which is Wi-Fi, is a totally different communication protocol because it used to deliver internet connection and supports also high-speed communications. It is backed by Wi-Fi Alliance, which gives the certificate only to which are fully compatible with Wi-Fi protocol, and it is mainly used in the short range, as I already said, to provide internet access both in a building and outside, and it supports repeaters, so also can create mesh networks. I have inserted this standard from between these protocols, even if it's not battery constrained, because the 81.11.10 standard is the most used network protocol in a home environment. So could be seen as an entry point for home IoT because we all have this kind of network. Then a brief recap of the devices that all support mesh network, Bluetooth only in its classic version. Then we have the ZigBee, the Bluetooth and the Wi-Fi that operates on the same frequency, so they could cause interference. Then in order to get this technology, you need an external hub for Z-Wave and ZigBee. I not put in this group also Bluetooth because the entry point is your smartphone, and Wi-Fi, well, you have a router in your home, I hope. So you already have the hub. Then, as already said, Wi-Fi serve a different purpose irrespective of the other three. In fact, it has a higher speed, a higher power consumption. Then coming in the end, the module price for accessing these devices are higher for Z-Wave because it is a private chip, and then lower going on till the Wi-Fi. So far, so good. Now we will briefly review some of the long-range protocols that are mostly used in the business sector. Perfect. I would like to start with these two protocols. So LoRaWAN and Sigfox. Analyze them both from what they are and from a business point of view. In fact, these two networks have similar characteristics, offering low power communication and low speed network at a range of about 10 kilometers from the gateway. LoRaWAN has been developed by LoRa Alliance, which is a non-profit organization that developed an open standard over a proprietary chip made by Semtech. So LoRaWAN is a protocol. Then we have Sigfox, instead is a French network operator that offers a complete stack IoT network. So we could identify Sigfox as a service. It's interesting to see what there is into a Sigfox chip in some devices. In fact, the chip also contains a CPU. That means that the full stack connection is within the chip. So we have LoRaWAN over LoRa, which is a modulation protocol, where the infrastructure is made by the user buying these chips. And instead, Sigfox has an infrastructure starting from the gateways and made entirely by a company. This means that to use it, you have to pay a monthly subscription like a normal telecom operator. I want to point out that LoRaWAN exists for LoRaWAN exists a similar Sigfox approach that is called TTN, is the Things Network, and is completely free. This infrastructure is made, in fact, by users that offers the gateway and connect directly to this network. So for who are they made? Well, LoRaWAN is perfect for makers, and because they have to acquire their hardware, their gateways, or you have to rely on TTN networks, and you can build your private network because the gateway is on your possession. Instead, Sigfox focuses on reliability of and network extensions. In fact, nowadays Sigfox extends over about 1 billion point 3 people. And these two kind of technology are within the low power wide area network. Instead, the next, which is another solution provided by 3GPP, is called narrowband IoT. And it is a cellular network that follows the architecture of LTE. It uses, in fact, the same LTE infrastructure. That means that the coverage is worldwide. Moreover, it uses a licensed frequency. That means it's less interface prone in respect of the LoRaWAN and Sigfox, which use only licensed one. Well, the technology gives all the guarantees of a cellular network, so internet connection, high capacity, and reliability. Then it's time for another recap. It's this time for long-range technology, which are more tailored for environment metering and services. If you would like to use this kind of technology as a private user, as a home user, I will surely pick LoRa, which has fewer costs and allows a private network. This feature is not provided by narrowband IoT and Sigfox because they are backed by cellular operator instead, and the downside is the one I previously mentioned, and the upside is that they provide high reliability and network coverage, which has its maximum for narrowband IoT that use LTE cell. Then we have Sigfox with its private gateways, and then LoRa, which in order to measure the coverage, we have to use the Things network. Talking then about mobility, we have the most with the LoRa because the signal of the devices reaches all the gateways. Then we have Sigfox and narrowband IoT, where the devices is coupled to the gateway. So there is a difficulty when changing gateway for Sigfox and cell for narrowband IoT. Well, that's all for me. And now give the word back to Naeem.
What are the communication paradigms? Communication plays an integral role in connecting the IoT devices. For effective communication, the protocols that offer lightweight, secure, and reliable communication without compromising the computational and energy limitations of the constrained IoT devices is the need of the hour. So, by keeping this in mind, there are two main communication paradigms. The one is request response paradigm, and the second one is publish subscribe paradigm. In request response paradigm, the client sends the request to the server and receives the response from the server. While waiting for the response of the request, client cannot send the second request to the server. So this way we can say that request response is a synchronous communication paradigm. The client requests for some data and the server responds to the request. Now let's discuss what are the publish subscribe paradigm. The publish subscribe is an asynchronous communication paradigm. It allows the development of loosely coupled event-driven architectures. It removes the dependencies between the producer and the consumer of information. Here the producer can be a publisher, which can be a temperature sensor, which publish the information to the broker, and the subscriber is the consumer of information, which subscribes for the information. We can discuss more in detail about subscriber, publisher, and broker in the coming slides. Here I will discuss the example related to publish subscribe paradigm. It is called MQTT, which is an acronym of Message Queue Telemetry Transfer Protocol. MQTT is a machine-to-machine Internet of Things connectivity protocol. It is a very light-based message broker publish subscribe protocol. Here I will call publish a subscriber as MQTT client. Any IoT object can be MQTT client that sends or receives telemetry data. This could be any device from a microcontroller up to a server. The type of the MQTT client, like subscriber or publisher, it depends on its role in the system. Both sends or receives data. Like, in order to distinguish whether the MQTT client is a publisher or it is a subscriber, first the MQTT client tries to connect with the messaging server. Here in this case it is message broker with the particular type of message topic. Once the connection has been successfully established, the client declares himself as a subscriber or as a publisher. Here to distinguish the data sent by the publisher, a topic string is always used. On the other side, if the MQTT client wants to receive data from the message broker, he must subscribe to the specific topic. Like by looking at this example, subscriber 1 is subscribing to the message broker with topic 1 and topic 2, and it will wait for message delivery from the message broker till the publisher 1 publish the data with topic 1 to the message broker. Like here, publisher 1 is publishing the message with topic 1 on the message broker. And then the message broker, as soon as it receives the message of topic 1 from the publisher 1, it will deliver that message to the subscriber 1. For example, another subscriber, like subscriber 2, is subscribing for topic 2 to the message broker. And there is a publisher 2, which will publish the message with topic 2 in the message broker. Here, the publisher 2, as soon as it will publish the message with topic 2 in message broker, the message broker will deliver the message to all the subscribers which are subscribed to the topic 2 on message broker. In this case, on the first step, subscriber 1 was subscribed to the topic 1 and topic 1 and topic 2, and the subscriber 2 is subscribed by topic 2. So message broker has delivered all the messages with topic 1 and topic 2 to all the subscribers which are subscribed with these topics. Like for example, here the MQTT client like time sense temperature sensor, which is a publisher. It sends data to the MQTT server, which is message broker, and publish the message with the topic temperature. And on the other side, MQTT clients that can be many, like here we have one-to-many relationships. So any MQTT client which would like to receive the data related to that topic, it can subscribe to the message broker. So in this case, we have a mobile and a backend device which is subscribed to the message broker with the topic temp. And whenever message broker receives the message from the publisher with the topic temp, it delivers that message to the subscribers. Here in this case are mobile and backend device. So for example, a client can publish temperature and also the humidity values using a different string for each value. For example, here the temp /25 or only the temperature. We can specify also the like room temperature and etc. etc. Like in IoT application, the main challenge is to effectively communicate between the machine to machine in the constrained network devices. Choosing the appropriate protocol is really difficult while developing the IoT application. The parameters like scalability, communication, management, and security, these are the certain criteria that the protocols have to deal with for their suitability in IoT environments. Thus, before choosing the protocols, we need to have the correct understanding about each protocol that we are going to use in our application. A single protocol is not sufficient in today's IoT applications. So we have to choose the protocols that that meets the requirements of our IoT application, like the communication and interoperability of the devices in the IoT applications. These protocols can be merged from standardized protocol for different layers befitting all the applications.
So we arrived to the end of our journey, and now we will show you how you could implement a real IoT platform using this technology. We will gather our data thanks to an ESP32 microprocessor, which is a very cheap microprocessor with both Bluetooth and Wi-Fi module, and the sensor will be the PME 280, which is capable of recording temperature, pressure, and humidity, and these two together cost about €5. One of the subscribers will be Telegraph, which is a plugin driven server agent that takes the data from MQTT to an InfluxDB, which is a database tailored for time series. And then the data will be displayed in Grafana, which is an open source analytics and monitoring solution. So what you're going to need? We will use Thonny, which is a Python IDE that supports also MicroPython, which is a Python version developed for microprocessor. We will use Docker, where all the architecture pieces will lay, And then we use IntelliJ to have a better visualization of what we are doing in Docker. So let's start. So we start with Phony Open. We need to flash the firmware, so we go to Tools, Options, Interpreter, and we make sure that we select the MicroPython for ESP32. Then we click Simply Install Software. Perfect, we select the correct port, which we connected our devices. We select the file, download from the link in the slides, and we simply click Install. Then we need to wait for about 2 minutes that the installation finished. I just cut a part of the installations. Perfect, we click Close, then OK. And here in the shell, you could see that the device has been recognized correctly. Okay, now we just insert in the boot.py file the name of our network, and we save on the device. And we click the reset button on the device in order to make the boot.py start. Okay, we wait. And now it should connect. Yes, has been connected to the network. And yes, these are the result of the print method. Perfect. Now we load all the files, which are 4. The first is the boot.py that starts at the starting of the device. Here we import the needed library like the MQTT, which is one of the 4 files. Here we define where to connect, for example, the IP of the MQTT server with the topic to which we subscribe or we publish. Then we start the module of the Wi-Fi and we connect. Then we go to the main file, which is the file that starts after the boot.py, where we import all the libraries. So we define some function, for example, the function of the token to which we subscribe, the function to connect to the MQTT broker, and the function to restart the device in order to redo the boot.py function and reconnect. Now we try to connect, and here there is the while cycle where we get all the infos from the sensor. I just use sleep 5 seconds in order to show you the data. This is the library of MQTT that does all the dirty work for us. And we get all the function to connect, to publish, so all we interface with this protocol. After this, we have the library of the sensor, of which the only things I want you to know is the 4 property from which we will read, which are the temperature, the pressure, and the humidity. Perfect. Now, we save all these files in the device by clicking File, Save Copy, and with the same name of the real name in your computer, because we need the same name because we import them in all the scripts. Okay, we save the file. Then all we need is the MQTT broker. And for this reason, we choose Click Mosquito and we deploy it thanks to Docker Compose. We expose the port to which we reach the broker, which is the 1883, and we just simply click the Start button and we are done. Okay, now we could open MQTT-FX, to which we could connect to the broker. We have to configure this tool in order to connect, so we just use the address localhost and the port 1883. I have already configured, so I leave it as it is. So just click apply, I will click cancel, then connect. And the green dot will show that you are connected. This is the topic to which you will subscribe, which is called home/hashtag. The hashtag is like a regex operator. and then just click subscribe, and you will have a subscription to this topic. Now, coming back to the device, we restart it and we wait for the connection, and then for the data coming from the sensor. Perfect, and here they are. Here the data coming, we see the topic for the temperature, for the humidity, and for the pressure. Now, we will build all the architecture. Here, the mosquito that we have previously built. Then we have Grafana, with which we will display our metrics. Then we have Telegraph, which is the plugin that allow us to take the data from TTT to InfluxDB. And in the end, we have also the InfluxDB, which is the time series database, which take the data from Telegraphs and make it available to Grafana. In the end, I also used 2 different storages in order to make the data persistent over restarts. The only things that we need then is to create these volumes, so Docker volume create and InfluxDB storage. And we simply click start. Okay, now the containers are running. It take not too much because I already downloaded the images. So here we see all our containers running. We have Grafana with the logs and the other one with type logs. So now we're going back to Grafana. I already open, so I load the page. I insert admin as the default password. I set the password with admin. Then we need to connect to InfluxDB. So we just need to settings, add the data source. We search InfluxDB. We set as URL the internal URL of the Docker network. So http influxdb.188086. Then as the database, we insert sensors, and as user Telegraph, and with password Telegraph. Okay, just click save and test, and we are ready to go. Then we need to create our dashboard. So just create dashboard. We add a new panel. Here we have to create a query just from the MQTT consumer, which is the plugin of Telegraph, where the topic is the humidity one. Here we removed the group by tag, and here our simple graph. Perfect. We add the name, and here we're ready to go. So this is the final result, and thanks for your attention.
Thank you very much for your attention till the end of the presentation.